So for our next example, you're going to need your calculator. You can pause the video if you need to get that out. And so on this problem, we're solving our trig equation. We've already got our trig function isolated. So cosine theta is negative 0.9. That's not on our unit circle, which is why we need our calculator. And so let's first rewrite this, taking the inverse of both sides. So we have that inverse notation. All right, so on your calculator, make sure that you are in radian mode. Okay, so I am, then you can hit second quit once you're sure. All right, so we're going to hit second cosine and then negative 0.9. All right, so our principal value is 2.69. It continues. You can just write to the nearest hundredth. And what we're going to do is we're going to store that value because we're going to need it later. So go ahead, if you've forgotten, you're going to hit stow right down here. Hit stow. And then we need to pick something to store it as. I like to pick the x, t, theta, n button if at all possible. If I'm only going to store one value, I pick that one because it's just one button. I don't have to deal with alpha or anything like that. So make sure you hit enter. Okay, now that value you can see is stored as x. So we're going to use that value to write our general solution equations. This is a cosine curve, so we're using our cosine general solution equations from the pink sheet. And so we're going to write our principal value, 2.69 plus 2 pi n, and the opposite of our principal value, so negative 2.69 plus 2 pi n. Okay, great. So then we're going to plug in different n values here, and n, remember, is an integer. So it could be 0, 1, 2, 3, and so on, or negative 1, negative 2, negative 3. Always an integer value. And so when n is 0, we're not adding anything to either one of these. All right. So when n is 0, we've got 2.69 and negative 2.69. And for me, it's easiest to just stick with one of my two equations and add and subtract 2 pi n. So we need to know when to stop, right? So our particular solutions need to come from 0 to 2 pi again. It won't always be the case, but when we're getting started, it will be. Okay, so we're looking to stop when we get to 2 pi, so let's think about that decimal approximation. Just in case you've forgotten, you can do 2 times 3.14 or just 2 times pi. Kind of have that in the back of your mind. So I like to think about that one. All right. So I know I'm going to stop once I get values at 6.28 or higher. Okay, so then I also want to kind of think about, does this make sense? If I'm starting at a positive value and I'm adding 2 pi, I'm going to use the pi button, I should get a value that's bigger than 2 pi itself. All right, so let's just double check. So we're going to say our 2.69 plus 2 pi times 1, so just plus 2 pi. Okay, so here's x, that's my 2.69, plus 2 pi. Yep, it's bigger than 6.28. So I know I'm not going to include that in my set. All right, now let's take a look at when n is negative 1. So 2.69 plus 2 pi times negative 1. All right, okay, so I'm going to say x minus 2 pi. You could also say x plus negative 2 pi. That would be fine too. Okay, so then we get this negative 3.59 value. All right, but remember, we're looking for values between 0 and 2 pi. So already we've got two values we don't even need. We're going to get rid of the negative. We're going to get rid of the value that's bigger than our 6.28, our 2 pi. So anything outside of that domain, we're going to exclude. Okay, so from this equation, we have exactly one particular solution. Now let's look to see if we have any more particular solutions. So for starters, we've got a negative when n is 0. So I'm not even going to bother looking for anything less than that because it's already outside of the domain. So I'm going to get rid of both of those. So then what I'm going to do is I'm going to look for negative 2.69 plus 2 pi n. I'm going to go to the calculator. So now I'm going to do negative x plus 2 pi. Okay, so I'm adding when n is 1, so just plus 2 pi. Okay, there's a value that's less than 6.28. So that's viable. We're going to keep that. And just in case, if you wanted to double check, Let's see what happens if we add another 2 pi. If you add another 2 pi, that's basically saying x plus 2 pi times 2. So I'm just going to say plus 2 pi. It's faster for me. And it's in line with what I'm doing when I'm not using the calculator. Okay, so you can see you get 9.8, way bigger than 6. Get rid of that. All right, so we now have exactly two particular solutions between 0 and 2 pi. So that's our theta. Okay, so then remember your general solutions are the equations. So we do have both, and you'll always want to make sure that you're paying attention and you're recording both as your answers. Okay, so we've got our general solutions and our particular solutions. Okay, so now that we've had a little bit of practice, we can go through these a little bit more quickly. So we're going to solve example 3 in much the same way that we did example 2. So we're going to start off by using our calculator and finding the principal value for the angle whose sine is 0.4. Okay, so you can plug that into your calculator. Again, you're still in radians mode, and store that. Again, I'll usually use x for the first one. Now, because this is a sine function rather than cosine, we have to use our sine equations, our general solution equations. So the first one is identical to cosine, principal value plus 2 pi n. However, the second one, be careful, it's pi minus pv. And so in the equation, you can write down pi minus 0.41, or what I like to do is I like to store that. So in the calculator, I'll type in pi minus x. You'll get 2.73, and I'll store that, but as something different. So I used x for the first one, I'll use a for the second one, and I like to write it down so that I know what I used. So now I'm ready to find my particular solutions. Those are our general solutions. And we'll go ahead and set up our table again. And so when n is 0, we're not adding anything, so we get 0.41 and 2.73. All right, we're looking between 0 and 2 pi, so between 0 and 6.28, just like before, and both of those fit. Okay, let's see if we can find any more. Well, a positive plus 2 pi is going to be too big. 6.69 is bigger than 6.28. That one's too big. And 2.73, also plus 2 pi, is going to be bigger than 2 pi. Okay, so we can get rid of both of those. All right, so then we'll take a look. Well, what if we subtract 2 pi? Again, from something positive, if you subtract 2 pi, we should be going less than 0, but let's just double check. It's no harm to punch into your calculator x minus pi. Yep, we get a negative. And then the 2.73, so use your stored value, so this time a minus pi. Yep, we got a negative. Okay, so we can get rid of both of those. So then we can see that we've got our two general solution equations, and you can leave the decimal version in there or not. That's up to you. You can leave them as is like this, or you can write it with the 2.73. Totally up to you. And then your particular solutions are the values that lie between the domain given. And in this case, we've got 0.41 and 2.73. Okay, don't forget to pause the video if you need to go back to anything. All right. So then we get into something a little bit more complicated when we've got sine of 2 theta. Don't let the 2 theta fool you. We're not going to do anything with the property just yet. We're just going to keep it as is, so just rewrite it with that entire argument. 2 theta is the angle whose sine is -1/2. All right, well, we can find the principal value here. That's on your unit circle, so we're not using a calculator this time. Okay, so we've got our principal value of -pi/6. So we're going to start off by writing our equations for 2 theta. We're not ready yet to jump to our theta 1, theta 2, so we keep this whole argument here. So 2 theta is your principal value plus 2 pi n. And remember, this is sine, so we have to keep in mind our pi minus pv. So our second equation is going to be pi minus -6. Be very careful. This is where a lot of people will make mistakes. They'll forget to do minus, and they'll just do pi minus pi/6. So be careful there. So overall, that's going to be 7 pi/6. Now is where we can get to our regular theta equation. and we're going to divide both sides of each of these by 2. Wait until you have the whole equation. If you just do it with your principal value or even your 7 pi over 6, you'll neglect to divide your 2 pi n by 2, and then you won't get the correct particular solutions. So divide the entire thing by 2, including your 2 pi n. So now in our general solution equations, we're going to have just pi n. Now the reason I have this extra little 12 over 12, if you can read the handwriting, is I like to have that common denominator fraction. So I divided negative pi over 6 by 2, I got negative pi over 12. Instead of just saying plus pi n, I'm going to say plus 12 pi over 12n. Same thing over here. I divided 7 pi over 6 to get 7 pi over 12, and I'm adding pi n, so I just called it 12 pi over 12. All right, and so I'm looking at going from 0 to 2 pi. I like to have that stopping point in mind, so I know it has to be in terms of something over 12. So I'm going to look at 2 pi and instead as 24 pi over 12. All right, so go ahead and test yourself. Pause the video and see if you get the same particular solutions. Try it out. Pause now. All right, so you worked through, and you should, of course, get, when n is 0, negative pi over 12 and 7 pi over 12. And since we're not taking any negatives, we can eliminate negative pi over 12, and then we don't even have to look for when n is negative 1. Then remember, we're just adding pi each time, or 12 pi over 12, so negative 1 pi over 12 plus 12 pi over 12 is 11 pi over 12. I'm going to add another 12 pi over 12, and I get 23 pi over 12. I'm going to check in. Okay, I'm still underneath that threshold of 24 pi over 12. If I add any more, I'm going to go over. Now I'm up at 35 pi over 12. That's too big. So I've got 2 particular solutions from this one equation this time. It's not always 1-to-1, so watch out. Okay, so then from my next equation, I'm going to do the same thing. I'm going to add 12 pi over 12, so 7 plus 12, okay, 19 pi over 12. I'm going to do it again. That's still underneath the boundary. Okay, that was too big. 31 pi over 12 is bigger than 24 pi over 12. All right, so I'll test it out. If I subtract 12 pi over 12, oops, got a negative again. So I got 2 particular solutions from this general solution equation. So this time we have 4 particular solutions, which is a little different than what we've been dealing with. So of course you'll rewrite those. We have our 2 general solution equations, we have our 4 particular solution equations. Okay, last we'll do a tangent example, and if you look at the pink sheet, notice that tangent only has 1 general solution equation. Okay, so we're going to start off, again, keep that big argument. Okay, so that's the entire argument equals 1, so we can think of this in terms of that argument is the angle whose tangent is 1. Remember, when we're looking at a tangent value being 1, that's when the ordered pairs match on the unit circle. So that's going to be root 2 over 2, root 2 over 2. So that's in our pi over 4 family. So our principal value here is pi over 4. Okay, so when we go to write our one and only general solution equation, we have to keep this big argument. So we've got theta over 2 plus pi over 3 equals our principal value, pi over 4, plus just pi n. Be careful with tangent, it's not 2 pi. Now we need to solve this equation. We're going to subtract pi over 3 from both sides. Then we still have theta over 2, so we need to get rid of that, multiply both sides of the equation times 2. So now we finally have our theta, one and only, general solution equation. And just like the last one, I like to have a common denominator. So I want the denominator over here to be 6. So I'm going to think of my 2 pi n, instead of as that, I'm going to think of it as 12 pi n over 6. Okay, well when n is 0, we just have negative pi over 6, which is negative. We're still looking between 0 and 2 pi. And I'm also using this as my stopping point. I know I need to stop when I get to 12 pi over 6. Okay, so I'm going to add 1 12 pi n over, or 12 pi over 6. When n is 1, I get 11 pi over 6. That's almost at my boundary. If I add another one, now I'm too big. So I have exactly 1 particular solution from my one and only general solution equation. All right, so now we can solve trig equations. We can use our general solution equations. We've done sine and cosine and tangent.